Good day, class. This time we'll be talking about the gravitational force. When we say gravitational force, it is a force applied, or it is a force that is also known as an attractive force. That means the force that is going to attract each others or each objects. Like for example, this one. We'll try, like for example, we have this earth or this land, and we are um corresponds to our weight right here, right? So there's a downward force or considered attractive force. That means every object or the force that going downward is what we call the gravitational force. That also equal to the force that applies from this one. The force applied or the gravity have a this force is going downward and then the force that going upward is equal. Like for example, you have 14 Newton here force, then that means you have also 14 Newton in your force. But this time, let's talk about how to get the weight, because weight is um has it's connected to our gravitational force in the Earth, which is given when you say gravitational force or what we call this one constant gravity of the Earth is has 10 Newton per kilogram. So we can get the weight. Like for example, so that's why it's some misconception of saying, oh, my weight is um, 30 kilogram. My weight because kilogram means it's mass. So they are different. So let's try to solve something. Okay, when you say weight, okay, let's try it here. Weight, you can put a W, which is the weight. Weight, okay. And then when weight is equal to is the same, this is the waiter. And then the formula of the weight is equals to mass times with the gravity. That means you have the mass constant mass. So it's the original well this one, original way of a certain thing or something objects how you weigh it. So a weight is it has its unit or of Newton. So because this is force. And we have here the mass. Yeah, we got this one. And we have the mass is equal to right, the mass is kilogram. That means, like for example, you're going to weigh something, so it's a kilogram. So the weight is the total force that applied, which corresponds to the gravity. When you say gravity, it's constant, which is 10 right here, gravity or gravitational strength. That's the same. So gravity is a meter per second squared, which is the gravity of the Earth, or we can call it a Newton per kilogram. They are the same. They are the same. Okay. So which is constant of 10. Let's try to solve something here. So we have here the weight. Okay, like if for example, teacher J has a mass of 60 kilogram. I am have a 60 kilogram. I write here 60 kilogram because this is mass M 60 kilogram. What you're going to do is you're just going to to multiply them. So up here, multiply with the gravity of 10. So right here, 10 Newton per kilogram. That means you say per, it's division. Okay. So we can see here in this solution that the kilogram is when you're going to times this one to n, so they become kilogram and n or Newton. Kilogram and Newton. Then divide with the kilogram, so the kilogram here will be cancelled out. So we can have 60 times 10 is 600. So teacher J has a 600 Newton. That's it. So let's try to have another one. Have another one. What if a certain box has a weight of certain box has a weight of 10 kilogram. So we can just simply like this one, then write the kilogram and then multiply with a 10. Another 10, which is the gravity. Write it at 10. So 10 times 10 is, don't forget to have the unit, because this is per. So the kilogram will be cancelled out because it's this one here is kilogram times the Newton is kilogram Newton. Then kilogram here will be cancelled out because it's division. They are the same, right? Then it's divide. Like for example, if you have one divide one, it's equals to zero. So it disappears. So here it's kilogram, same as a kilogram, divide 10. So the kilogram will be disappear. So 10 times 10 is equals to 100 Newton. So that is the weight. How about teacher if there's a given weight, but we want to find our mass? So what we're going to do, teacher? So okay, let's solve that. Let's solve that. This time, we are going to derive the formula. We have to divide each side um, by its if what is you are looking for. Like for example, you are looking for the mass, right? So the mass has its what we call this one has its um since the mass is with the gravity. So what we're going to do if since we're looking for the mass, we're going to divide them both sides with the gravity. Both sides. So we have here this division of what I have said earlier. If they are the same, that means you are going to cancel them out. So this is the formula that you're going to use, which is the mass is equals to the Newton. It's very easy. Students, Newton divide the gravity. So the mass here, like for example, it's of 7. Okay, you have 60 Newton. Okay, have 60 Newton. And then the gravity is Newton per kilogram. So we have here 10 Newton per kilogram. So the answer will be, can I keep M here, it's a mass. So the Newton will be cancelled out because they are the same, right? And it's division. So 60 divided 10, what is your answer? 60 divided 10, it's 6, it's correct. So 6 kilogram is the mass. That is very easy. Okay, that will be all for today's class. Goodbye and thank you. Have a good day. This is Teacher J, your teacher in science. Bye.